Okay. Hello, everyone. Good morning. So, I will start my presentation taking an example from North America, where a utility has adopted a new kind of asset monitoring and management approach. Definitely, it is Pepco Holding, as you can see it. And now I will show you what they did. So, it was one of the major Pepco substation. One transformer was taken out for service and load was shifted to other transformer. What they found is that a 200 MVA transformer began to rapidly gas. They inspected this transformer, temporarily repaired it, and returned to the service. But later on, when they again when the load was shifted again into this transformer, it showed the same kind of behavior. And finally, it was replaced by Pepco Holding. Another 250 MVA auto transformer at a DPL generation facility was nursed to replace using the same system. So Pepco Holding had a monitoring system which benefited them into saving the cost of sudden failure and saving the cost of unplanned outage or unplanned maintenance. So how did they do it differently? They installed online DGA monitor on their top 100 critical transformers. So they were continuously monitoring the dissolved gases into those critical transformers. They connected all of these DGA monitoring system to a central database, and this system provided them at a glance status checking and drill down for quick problem identification. And it also enabled a broad access to the data of 100 transformers. The software, they used a very simple software. So their software user interface was a region level view which showed all the transformer of that particular region, then a substation level view, and then an asset level view. In region level and substation level view, they were having simple 3 alarm lights. The left alarm indicated something is happening in any of the transformer of that substation and gassing is happening into that transformer. The middle light indicated the monitor of that particular transformer, so whether the DGA monitor is on or off, and the right light indicated the comms status. What are the status of the communication between that monitor and the central database? And at the transformer view, it has a quick indication of the gas levels. So once you click on the transformer level view, you can easily see each gas and the level of that each gas. And once you click on this transformer, it takes to the TM view screen which comes with DGA. So this is the simple approach they followed, and this approach basically helped them to identify the bad actors, help them what was the main reason for a particular kind of behavior into a transformer, and help them to replace the transformer well in advance. And in terms of data security, they did not do a rocket science. What they did, they ensured that these monitors should not be having any direct access from the outside network. So the data from substation assets is delivered via a secured private network, and different personnel are having different level of access to the monitoring data. Okay, so taking this example, what what Pepco Holding did, similar kind of approach is now being adopted by many other utilities. You name those utilities, whether it is National Grid or Scottish Power in the UK, Kahrama, OETC, Oman Electric Transmission Company, or EWA in Middle East. So all the utilities now they are thinking of adopting such kind of approach and monitoring their fleet of transformer from a single location. So today I will talk about this new approach and I will cover new trends in transformer monitoring, expectation from condition monitoring, what are the expected output utilities are looking from condition monitoring, challenges associated with this kind of condition monitoring, and what could be the possible solution of those challenges. So I'll briefly talk about monitoring architecture, how a good HMI should look like, what kind of reporting should be there in that system, what kind of data security should be there, and I'll briefly touch on transformer health assessment and futuristic approach going forward from this kind of asset management and monitoring approach. Okay, if we talk about transformer monitoring, now utilities are going for monitoring all the critical parts of the transformer. If you talk about bushing, they are going for continuous online monitoring of capacitance, stand delta, and partial discharge activities on the bushing. On the LTC, they want to know if the tap positions are changing, they want to know what was the change. They want to know about the contact wear of the tap position of the LTC. They want to know the switching time, whether the switching time is appropriate or not, or is there any deviation on the switching time. They want to know whether the motor is working fine or working as per the specification for the LTC. They want to monitor the key gases generated inside the tank, and they want to analyze the overall health of the transformer, or they want to identify the faults which are generating inside the transformer responsible for those gases. They want to monitor hottest spot into the winding of the transformer, be it is using a fiber optic or using a conventional method. They want to monitor the fan banks and pump status of their cooling system, and they want to monitor some other bunch of parameters, for example, temperature of the tank, pressure of the tank, oil level, load, moisture, partial discharge inside the tank, and membrane rupture. Apart from these parameters, there is a need to have models that can provide assessment of insulation aging, lifetime consumption, moisture in insulation, and bubbling temperature. So these kind of parameters utilities are looking to monitor, and they are looking from a transformer monitoring system to have a continuous monitoring of these parameters and have these models built into the system. Okay, but what are they really expecting from this huge investment on condition monitoring? The expectations are this system must prevent major failure and optimize maintenance by reducing the cost of sudden outage and avoid unnecessary maintenance visit. It should achieve better utilization of load capacity. So they want to closely watch the units, the transformers that are at higher risk level, or the transformer which are critical to them. And they are looking for some expert decision support system for load shifting and better utilization of available capacity into the network. Extend the remaining lifetime by comparing the health related parameter of a transformer with the benchmark data from the OEM or with the benchmark data from the normal operation, or they want to do the failure pattern analysis, and depending on the failure pattern analysis, they want to predict the life of the transformer of the same family. They are also nowadays, mainly in the developed world, utilities are also looking for a simulation tool which will be used for training their new staff, and they are looking for a knowledge-based system which will provide the situations to the new staff and also give the analysis of the decisions taken by the new staff. But what are the challenges associated with such kind of monitoring? You have seen that there are number of parameters to be monitored, number of models to be incorporated into the system. But what utilities are facing the challenge is there is a big gap between getting the data to a central system and having a single monitor which can monitor all the parameters. So in order to achieve such kind of monitoring, utilities are entering into a vicious cycle of condition monitoring. I'll call it a vicious cycle of condition monitoring. So if you take, you can take any of the circle here. So let's take the circle more monitoring parameters. So they have, for example, currently they have 20 monitoring parameters. In order to monitor these parameters, they are buying different vendors, different monitoring system. Different monitoring system are having their own different database, their own different screens. So the data which they are getting is scattered and unorganized. This scattered and unorganized data is resulting into no integrated information available to interpret the overall health of the transformer, and a bad interpretation of the health of the transformer is resulting into a poor maintenance decision. So ultimately they are thinking that they are not monitoring enough number of parameters. They are increasing more number of parameters and they are entering into this vicious cycle. Apart from that, there is a strong need of a system which should be having a overall health assessment of the transformer. It should give a kind of risk index for a transformer. That could be either by correlative analysis of different parameters or building an accurate knowledge-based database. Just to give you an idea about the volume of the data that would be expected from the transformer. So you have these many sensors to be placed on the transformer. These sensors every minute, and in fact I would say some of the sensors you are expecting data at every 20 milliseconds. So you are getting data out of these sensors on an average every minute. And every minute this data should be stored into some database, and that database should be having an analytics to correlate the different parameters and give you the continuous or real-time health assessment of the transformer. So you can see the data volume that you are expecting from one transformer. Now you can see if you connect 100 transformer, what kind of data volume we are expecting. So what could be the solution? Solution should be an integrated system which will have fast, reliable, real-time sensors, a monitor to capture the data received from the sensor, and a central database which will prioritize, organize the data, and this database will be accessed by an expert analysis system, and that expert analysis system should be based on severity analysis, correlative analysis of different parameters. And this expert analysis system should be used to identify the overall health of the transformer. And definitely there should be a easy to understand user interface to access such kind of system. So what should be the monitoring architecture? We think that monitoring architecture should look like this. So we are just taking the same thing, whatever Pepco Holding has implemented, we are just expanding on the same thing. So if you see that at each transformer, there is a local transformer monitor, and all the local transformer monitor are connected with the substation control room. So all the data about all the transformers inside that substation is going to the substation control room, and a person sitting in the substation control room is having a picture of all the transformer, a picture of health of all the transformer. All such kind of substations are sending data to a corporate headquarters, where a person sitting on the corporate headquarters can see the entire fleet of the transformer from one location. And the data at the corporate headquarters or at the substation control room or from the local transformer monitor should be accessible from the remote client or web client. So this should be the architecture this should be the futuristic architecture of the monitoring system. In fact, if you go down the line 2 years or 3 years, all this data should be available in the mobile application of the asset engineers or asset operation engineers. So if you talk about the visualization, I just took the visualization from the monitoring architecture. So when you are sitting at the corporate headquarters, you should be having a view of your entire fleet of the transformer. So this particular view is called a region level view, which will have the overall status of the region. If you are sitting at the substation, you should be having a substation level view. Or again, if you are sitting at the headquarters, you should also be having the access of the substation level view. And if you are looking at the local transformer monitor, then the local transformer monitor should be having a view of the local transformer health, a view of the real-time data which is getting from the sensors. But for the headquarter person, he should also be able to see individual transformer if required. And for an expert, for example, our utilities are having experts on partial discharge, expert on DGA, expert on LTC monitoring, expert on cooling system monitoring. So those experts should be having a larger data or models to analyze the health of individual parts of the transformer. So individual parts should be having their own separate UI or separate models to analyze the health of the individual part. So as I explained you, region level view, a region level view should be showing all the substation of the utility across the region. So this is an example of the GCCIA link. So GCCIA link is spreaded all across the Middle East countries. So there are around 18 substations. So all the 18 substations should be shown in that region level view. Any transformer having any problem in any of the substations should blink in the red. So sitting at the corporate headquarters, if you are seeing your region level view, everything is green, it means all of your substations are working fine. If any of the substation is blinking red, yes, you got a problem into that substation. So what you will drill down into that substation, then it should take you to the next substation level view. Apart from this kind of region level view, you should be having your top 10 critical transformer here. So if I'm sitting at the corporate headquarters, I should be having an access of my top 10 critical transformers, or I should be seeing the health of my top 10 critical transformer every minute, 24 hours. And if I click on the substation level view, I should be seeing the substation diagram, whether it is 2D or 3D, then with all the assets on this substation diagram. Again, any transformer having a problem, whether it is a TGA problem, whether it is a LTC problem, whether it is a bushing problem, that transformer should blink into red. And once I click on the transformer, I should go to the transformer level view. Again, if I roll over into this transformer, I should be getting a summary of the health of the transformer. That summary may be a dual triangle with existing status of that dual triangle, or a summary of the current load, a summary of the current oil pressure, a summary of the current LTC position, current capacity utilization, whatever customer would like to have. So it should be flexible enough for a customer to configure this rollover functionality, to configure this entire, you can say, screen. If I go to the individual transformer or individual asset level, then I should be seeing that particular transformer with all parameter status. So this particular screen should be having temperature, oil pressure, oil level, your bushing monitoring parameters like capacitance, 10 delta, partial discharge, your DGA related parameters, your tank partial discharge related parameters. Whatever sensors are installed into this transformer, those sensors should be shown into this particular view and with their current value. Any parameter crossing the alarm limits should be shown as a red color, and once I click on this red color, I should go to that particular section. So coming to the individual section of this particular system, the individual section should be having a detailed analysis screen of that particular parts. For example, if it's a DGA, then there should be having a facility to see the dual triangle, facility to see the Roger ratio, facility to see the Durenberg ratio, or some advanced models like tone. If it is a LTC monitoring, I should be having facility to see my inrush current, steady state current, my power consumption of motor, my different tap positions, the history of different tap positions. Everything I should be able to see in that LTC monitoring section. If it is a cooling system monitoring system, I should be able to see how many times my fan bank has run, how many more time my fan bank can run, what's the inrush current, what's the steady state current of my fan motors or my pumps. If I'm seeing the bushing monitoring, I should see the capacitance and 10 delta trend over a selected time period. If it is a partial discharge monitoring, I should see if there is any partial discharge signal inside the tank. If there is a partial discharge signal inside the tank, what type of partial discharge signal it is. So all kind of PRPD related screens, PRPS related screens should be there in that section, and other parameters like temperature, pressure, and other stuff. Then in terms of reporting, it should provide the reporting right from the region level to the substation level and to the asset level. So if I'm sitting at the corporate headquarters, if I want the report of each of my substation, just by clicking one button and selecting the substation, it should automatically generate the report of the health of all the transformer in that substation. If I am at the substation level view, I should be able to generate the report of all my transformer being monitored in that substation. If I am at the transformer level view, I should be able to generate a report of all the parameters on that transformer. In terms of data security, all the IEDs which are local transformer monitor should not be accessed directly from the network outside of the utility network. If they want to have an access of this network, they should be either having a virtual private network access, or they should be directly connecting to the central database, or you can say substation level database. Any communication out of the database, any communication from outside the utility network should go from this secured network of the utility, and there should not be any write access to these local transformer monitor. Coming to the transformer health assessment, so as I explained you, comparison with benchmark data. So the system should be having a facility to compare or to have a fingerprint analysis, either using a design type data or using the previous test. Interpreting using well-known methods. For example, this should have all the available well-known methods for dissolved gas analysis, for LTC monitoring, moisture in insulation monitoring, winding temperature, lifetime consumption, insulation aging. So all sort of models should be available into such kind of system. A trend analysis and data mining techniques can also be implemented into this system. I was talking about having a knowledge-based database. So that knowledge-based database should be used to develop the artificial intelligence and neural network-based analysis algorithm, which will ultimately get trained on this fault database and the event database, and will be used to come up with the risk index of a particular transformer. And the transformer monitoring system should also be having a facility to log the offline testing data. So if utilities want to do the offline testing like frequency, response analysis, DP analysis, Furon analysis, if they are doing those kind of analysis with the transformer, then this particular system should be having a facility to enter the results of these testing into the database, and this entered data should be used in all of the future analysis algorithm, all of the future trending, in all of the future, you can say, models. If I talk, so till now I have just talked about the transformer, and we have seen that utility like Pepco Holding have got advantage of having such kind of a structure. They were just monitoring one DGA and they were just getting the data from one DGA. And if utilities, they get the entire data about the parameters of the transformer, then definitely it will help them in scheduling a maintenance, in doing a planned outage, in doing the load shifting among the transformer. But in future, such kind of monitoring system should also have a facility to integrate other assets. So tomorrow, if they want to integrate the breaker monitoring system, if they want to integrate the GIS monitoring system, so this kind of system should be having a flexibility to integrate such system. As an example, if we just talk about the breaker, so there are a bunch of parameters that can be monitored into a breaker, and that can be fed into the same system. So same system can be used for analysis of the entire substation assets. So the future is multi-site, multi-asset condition monitoring platform, a platform where data from all these assets be it is a transformer, be it is a breaker, be it is a battery, be it is a surge arrestor. All the data is coming to a central location, getting analyzed, and utilities are using that system to do their condition-based maintenance.